Welcome to the DIY Honda Garage channel. DTC P0098 indicates an issue with the IAT, intake air temperature sensor 2, circuit reporting high voltage. The IAT sensor is crucial for determining the intake air temperature, which helps the engine control module, ECM, adjust fuel delivery and ignition timing for optimal engine performance. This specific sensor is typically located in the intake manifold, or air intake ducting, where it can accurately monitor the air temperature entering the engine. High voltage readings from this sensor may lead to poor engine performance, increased emissions, and potential engine damage if not addressed promptly. It's essential to understand that this diagnostic trouble code, DTC, can be triggered by various factors including faulty sensors, wiring issues, or connectivity problems. Proper troubleshooting is crucial to pinpoint the exact cause and ensure the vehicle operates efficiently and reliably. The P0098 code signals a problem with the IAT sensor 2 circuit experiencing high voltage. The IAT sensor provides the ECM, or engine control module, with real-time data on the intake air temperature. This data is vital for the ECM to make adjustments to the air-fuel mixture and timing to ensure optimal engine performance and efficiency. The IAT sensor is commonly located either in the intake manifold or within the air intake ducts. It consists of two wires that connect it to the ECM, allowing it to communicate temperature readings. The high voltage condition, defined as readings exceeding 4.92 volts from this sensor, suggests there may be an issue, such as a faulty sensor, a short circuit, or possible wiring problems. Understanding the sensor's role and specific location is crucial for effective troubleshooting. Several possible causes can trigger the P0098 DTC. First, a faulty IAT sensor can yield incorrect voltage readings, which can lead to high voltage signals being reported. Secondly, wiring issues such as frays, breaks, or shorts can lead to erroneous voltages and should be thoroughly inspected during troubleshooting. Poor connections, including loose terminals at the IAT sensor or the ECM, can interfere with proper signal transmission, resulting in high voltage readings. Additionally, external factors such as extreme temperatures or moisture ingress affecting the sensor can lead to incorrect output signals. It is also crucial to consider that the problem may be intermittent. Thus, proper diagnostic checks are often essential to pinpoint the issue accurately. When the P0098 DTC is present, there are several symptoms that drivers may experience. The most noticeable is the illumination of the check engine light on the dashboard, alerting the driver to a potential engine issue. Additionally, the vehicle may exhibit poor engine performance characterized by sluggish acceleration or uneven idling, caused by the ECM's inability to optimize the air-fuel mixture effectively. Increased emissions may also be a concern, potentially leading to failed emissions tests. In severe cases, the engine could stall unexpectedly, causing safety concerns while driving. Identifying these symptoms early can aid in the timely diagnosis and repair of the underlying issues related to the IAT sensor. The first step in troubleshooting the P0098 code is to turn the vehicle to the on mode, ensuring all electrical systems are active without starting the engine. Using the HDS, which stands for Honda Diagnostic System, check the parameters of the IAT sensor 2, specifically looking for its voltage reading. The parameter threshold is critical in this instance. If the voltage exceeds 4.92 volts, the conditions suggest that the failure can be reproduced, leading to step 2. However, if the readings fall below this threshold, it indicates an intermittent failure, suggesting that the system may be functioning correctly at present. In such a scenario, it's essential to examine all connections at the IAT sensor 2 and the ECM for any sign of poor connections or loose terminals that could cause intermittent issues. In the second troubleshooting step, ensure the vehicle is turned to the off-lock mode to safely disconnect components. Disconnect the IAT sensor 2 using the 2P connector to isolate the sensor from the system for further testing. Using a jumper wire, connect terminals A and B of the IAT sensor 2's connector to create a direct connection, bypassing the sensor. Then, turn the vehicle to the on mode once more and check the parameters with the HDS system to observe the voltage of IAT sensor 2. If the readings remain above 4.92 volts, it indicates that the circuit is functioning correctly, and you can proceed to step 3. Conversely, if the readings are low, this calls for the replacement of the IAT sensor due to its likely defective nature. In this third troubleshooting step, turn the vehicle to the off-lock mode to ensure safety while working with the electrical systems. After removing the jumper wire previously used, switch the vehicle back to the on mode to check for voltage readings. Measurement should occur between the specified test points, namely points 1 and 2, where test point 1 is connected to IAT sensor 2's number 1 connector, and test point 2 is grounded to the vehicle body. At this point, you are looking for a voltage reading of approximately 5.0 volts. If this voltage is present, proceed to step 4 to continue diagnosing the issue. However, if the measurement deviates from this expected value, investigate further, as this may point to issues within the INTA line or other related wiring malfunctions. For the fourth step, turn the vehicle to the off-lock position for safety before performing electrical checks. Use the HDS to create a short circuit by jumping the SCS line, thus engaging the diagnostic mode of the system. Disconnect the PCM connector C, which contains a total of 51 pins, to isolate the control module from the circuitry for accurate testing. Check for continuity between test points 1 and 2, with test point 1 being the IAT sensor 2's number 2 connector, and test point 2, the corresponding pin, number 31, on the disconnected PCM connector. A continuity check will confirm whether the SG2 wiring harness is intact. If continuity is confirmed, contemplate updating the PCM or substituting a known good PCM as part of further troubleshooting to eliminate the root cause of the P0098 code. The fifth step involves repeating some of the previous procedures to verify the INTA line's integrity. First, ensure the vehicle is in the off-lock mode for safe handling. Again, jump the SCS line utilizing the HDS to engage diagnostic functionalities. Proceed to disconnect PCM connector B, also comprising 51 pins, to further isolate the electrical pathways. Continuity testing is essential here. Between test points 1, connected to the IAT sensor 2's number 1 terminal, and test point 2, linked to pin 42 of the PCM connector B. If continuity is observed, it gives insight that the INTA wire is functioning correctly. Highlight the importance of updating the PCM software if it is not the latest version, or substituting in a known good PCM. This step is necessary to confirm that all systems are operational and continue troubleshooting if the error persists. After completing all necessary repairs for the P0098 code, the final step involves verifying that the fix was effective. Begin by clearing any stored diagnostic trouble codes using the HDS, ensuring the engine computer is reset to monitor fresh vehicle performance data. Following this, performing a test drive is crucial to assess all driving characteristics and ascertain that the vehicle operates normally without any warning lights. During the test drive, pay attention to engine behavior. including acceleration, idle smoothness, and response to throttle input. After completing this assessment, recheck the PCM with the HDS to ensure that no new or previously recorded DTCs have reappeared, thereby confirming that the issues have been successfully resolved and the vehicle is operating optimally. To prevent future occurrences of DTC P0098 and maintain optimal vehicle performance, incorporating preventive maintenance is paramount. Regular inspections of the IAT sensor can help catch issues before they escalate, allowing for timely replacements when necessary. Additionally, schedule periodic checks of the wiring harness associated with the IAT sensor to identify any wear, fraying, or potential shorts. Ensure that all terminal connections, including those at both the IAT sensor and the PCM, are tight and free from corrosion. Addressing these maintenance tasks proactively not only helps in extending the life of the components involved, but also contributes to overall engine efficiency and performance in the long run. In conclusion, understanding the symptoms and underlying causes associated with DTC P0098, which pertains to the IAT sensor 2-circuit high voltage, is essential for effective vehicle maintenance and repair. A structured approach to troubleshooting helps in accurately pinpointing issues, allowing for efficient repairs and the restoration of vehicle functionality. By following the troubleshooting steps laid out, mechanics can systematically identify faults either in the sensor itself or the wiring and components connected to it. Moreover, engaging in preventive maintenance practices can significantly reduce the likelihood of this DTC recurring, ensuring the vehicle operates smoothly and efficiently. Ultimately, staying informed and proactive in vehicle care can lead to improved performance and longevity for the Honda Fit. Please like and subscribe to the channel. See you next time.